So we've already looked at doing some problems where we have different pieces put together. Simple problems like this. And let's assume that all these are right angles. That look like they're right angles at least. So let's give you some dimensions here. Let's say that this is 12 inches. We'll call this one 8 inches. This here we're going to call 20 inches. Across the bottom here, we're going to call this, let's see. "48 inches, let's say. I'll call this 20 inches here. Find the area and perimeter. Where would we start? Maybe finding the area first would be easiest. So how would we divide this up if we were finding the area? Obviously, we cut off the triangle. We'll call that piece 1. Take this off the top like that. So we'll call this 2 and 3. So for area, piece 1 is a triangle that's 20 by, well, the 20 is this. Do we know any of the other dimensions? What's this dimension here have to be? Careful. That's 48 from here all the way to here, right? 12 and 20 make 32 across there, right? So this piece here has to be the difference, or 16. Does that make sense? So in the area, it's going to be 16 times something. This is the other leg. We need to know that size. Can we find it? How? Perfect. 20 squared minus 16 squared. It's that reverse Pythagorean rule. So 20 squared, 400. 16 squared is 256. That subtracts to make 144. Then, of course, we have to square root it. Square root of 144 is 12. So this across here is 12 inches. So to find that area, it's going to be 16 inches times 12 inches divided by 2, because it is a triangle. That's 96 square inches. How about for rectangle, the piece 2 there, the rectangle? Well, we know it's 12 here. What's this? 32. We've already found that up above. So that's going to be 12 inches by 32 inches. It's a rectangle, so we don't have to divide. So that's what, 384? I believe. I think that's right. And then piece 3 is a rectangle that is 12 inches by 8 inches, or 96. So we add those all up, and we get what? .576 square inches, I believe, is my area. How do we find perimeter?
12 on the one and the other side.
Just going to add them up, aren't we? 12, 8, 20, 20, 48, and 20. 12 plus 8 plus 20 plus 20 plus 48 plus 20, which is 128 inches. Is that that look right? So that wasn't bad. Pretend the top and bottom are parallel there. Find the area and perimeter, something like this. I'm actually going to give you a couple minutes to start that in your notes, see if you can get it outlined, and then we'll go. Okay, so how would you go about this? Probably cut off the half circles on each end. Then we do need to know what this length is here. How are we going to find that? Yeah, we got, if that's 40 across there, that means the diameter of our circle is 40, which means the radius is 20. So it's going to be 20 here and 20 here. So we subtract 40, this is 120 feet across there. So for area, we've got the rectangle that's 120 by 40, or 4,800 square feet. What do we do about those other pieces there? Well, we've got a half circle there and a half circle there. I'm going to take them and do this. And I now have a full circle with a diameter of, or no, diameter of 40 and a radius of 20 feet. So that area is pi times 20 squared. Do I have to divide it by 2? No, because I put them together to make a full circle. So rather than finding 2 half circles, I can just find 1 full circle. So it comes up to 1,256 square feet. So that is 6,056 square feet is the area of that figure. For perimeter, I have 120 feet here and 120 feet here. Plus, I've got the 2 curves. But I can see here that's just one circumference of that circle. The circumference of that circle is going to be pi times 40, or 125.6. So it adds up to 365.6 feet. Not so bad? So let's take the next step. So let's say this one is 200 feet here, 60 feet across here, and 10 feet across there. Find the area. I'm just asking for the area this time. We'll talk about perimeter in a little bit. Find the area of that highlighted part, the track. Again, I'm going to give you a second to look at it, see what you can think of. We'll go from there. So, the way I would divide this up, similar to what we did before, just like this, cutting off the half circles on each end. But now we've got 2 rectangles here. So each of those rectangles is 20 feet or 200 feet by 10 feet, or 2,000 square feet. So I'm going to write that down twice because there's one here and one down here. For the circles on the ends, however, this is actually a type of problem we've seen before. Where we have a bigger circle with a smaller circle cut out of the middle. We did an area of a washer like this before, where we're trying to find this area of the ring or the washer. You remember how we went about doing that? What's the radius of that large circle? 30 feet, yes, half of our 60. So the area of that large circle is pi times 30 squared, otherwise known as 2826 square feet. What's the radius of the small circle? 20. Yeah, if this is 10 feet here, 30 minus 10 leaves that 20 feet. So that's pi times 20 squared, otherwise known as 1256 square feet. So now we can subtract get 1,570 square feet is the area of that highlighted piece. So that's this area and this area that we're going to add to this. So that gives us a total of 5,570 square feet of area. Does that make sense? So now our perimeter is the same as what we did before. Only I have an outside perimeter and I have an inside perimeter. My outside perimeter, I've got 200 and I've got 200. Plus the circumference of the outside of that, which is pi times 60, right? Otherwise known as 188.4. So that adds up to 588.4 feet of perimeter on the outside. If I do the inside perimeter, it's still 200 plus 200. Because these two straight pieces are still 200 feet long. Now it's just the circumference of the smaller circle. That is a 20 radius, so it's pi times 40, it's 40 diameter, which would be 125.6 feet. So that adds up to 525.6 feet inside perimeter. Does that all make sense? Okay, so I've got a fun one for you here. That's a square. Those are half circles. Each side of the square here is 10 feet. In your notes, find area and perimeter. This one's not as bad as it looks. For area, we've got the rectangle inside here. I'll call that shape 1. That's just 10 feet by 10 feet, or 100 square feet. There's 4 half circles out here, which basically make 2 full circles. So that's going to be 2 times pi times what squared? 5 squared is each radius. So that multiplies up to be 157, right? So 257 square feet. Each of them was 78.5 times 2 is 157. So the total area is just 257 square feet. The perimeter is actually even simpler. Does that square contribute anything to the perimeter? No. It's just the circles. The circumference of that circle is pi times 10. And there's 2 of them. Times 2, right? These 2 make 1 full circle. Those 2 make another full circle. So that ends up being 62.8 feet. And that's it. What do you think? Better than a sharp stick in the eye? Okay, it's a couple minutes early, but let's go ahead and take our break. We'll come back at about 8:28 and we'll go from there.